Cool. Now in video 2, we're going to learn about data types and computations. The computer is basically just a smart calculator. That's why it's called that. It can do computations. It uses a series of binary code of ones and zeros to run, and so you guessed it, it can do math as well. The modern computer can read many data types, and we can just start with two that represent numbers, integer and float. Integers are just like math, your OG whole numbers, 1, 0, 99, etc. Floats or floating point integers are numbers with decimals. Sometimes they're also called double. Float equals fraction, so think about stuff you normally would write as a fraction as floats, 1.25, 2.5, etc. There are also data types that represent actual English. We call these characters chars or chars or strings, like a string of letters. Chars are single letters A, B, C, etc. Strings are words like hello, world, and Python. To define chars and strings, you need quotes. As mentioned, Python doesn't really care, though usually we use single quotes for chars and double quotes for strings. Longer stuff, more quotes. A third category is called Boolean. These represent true-false scenarios, and this is really useful for decision making, like yes or no. Computers use binary code, which is a series of 1-0 true-falses as well. Now, let's do some simple math. Let's try to calculate 3 plus 5. So to do this, once again, we want to print the output using the print function. The result of 3 plus 5. And this is just text that we already practiced writing earlier, and it's just good to write it again to get the hang of strings and stuff. And then you put a comma next to it, and then from the comma, you put the actual thing that you want the computer to print. So in this case, you want the computer to calculate 3 plus 5 and take that value and attach it to the end of this string. And Python will automatically do that for you. And if you click run, it should print out the whole thing. The result of 3 plus 5 is 8. We might have just done addition, but you can literally do any math function on a computer. There's the basic addition and subtraction, and also multiply and divide, which is represented by the star symbol over here, and also the / symbol. There's even a floor function that gives you the remainder of a calculation, and this is also known as floor division. When doing math, remember the rules of PEMDAS. Please excuse my dear Aunt Sally still exist for the computer, so use parentheses when needed. Memory. We all have it, and computers have it too. To store stuff in memory, we use variables, much like in algebra. Let's write some pseudocode first, which is just fancy for fake code. Pseudocode is good for design thinking through your code at first. The question we have here is calculate x plus y by assigning values to these variables. We have two variables, x and y. Let's assign 30 to memory x and 60 to memory y. In math, you might do x equals 30 and y equals 60. Much the same here, except you would read it right to left. That's an important difference. 30 is assigned to memory x in terms of the computer. Now that we have them in memory, we can even manipulate them. Let's create another variable called sum. Once again, the computer reads right to left by assigning the thing on the right to the variable on the left of the equal sign. Another quick thing, equal is used for assigning. If you want the actual equal sign, you will need to type out equal equals. Now let's just do what we wrote in pseudocode real quick. Once you get your design out, it's really simple to implement it. X equals 30, y equals 60. Our variable sum is going to equal x plus y. And then ultimately we want to print out sum. Okay? And it should give us 90, which is correct. Now, one final thing to note is remember that you're reading top to bottom, or the computer is reading top to bottom. Things can be reassigned and changed. So if I were to change this x up here to something different, let's say we change x to equal 40 now. That's going to affect our sum later down. And when we try to print sum again, x is first containing the value of 30, then it's changed to 40. So when it calculates the sum, it's going to be different as well. And yep, you can see 60 plus 40 is now equal to 100. So the old value of 30 gets erased and replaced. And so that's what's affecting the sum as well. We talked about packages earlier, and we can import stuff like packages. We can also import simpler things called libraries that give us special functions normally not loaded by the computer. For example, if we import math, we get the square root function and a bunch of other functions. Now let's try calculating square root 2. First, of course, we want to import the math library. So at the very top, you always want to do this before all the code so the computer knows to load this library in. So import math. All right, so now we know it's within the whole program. And now we can type what we want. So for a math function, you want, once again, print because you want to see the result. You don't just want the computer to calculate it and hold it. Math dot square root. This takes the square root function and calls it from the actual math library for use. And now you can just put a number in there that you want. So square root of 2, of course, we know is about 1.414. And if we run, yep, it tells us a pretty precise value. So that's pretty good. Finally, we'll finish up with user I/O, or input-output. You've learned all these skills, so why not let someone else use the fun you've created? One note is that unlike the math library, this I/O is built into the Python, so there's no need to import anything. Let's create a program that will convert Celsius to Fahrenheit, because as Americans, we really don't get this whole Celsius thing. This is a conversion you can simply search online. And so first, I'm going to create a variable so that this can take in the input function and actually do some calculations on it. Let's create this variable and call it input. And this is a string input because that's what the input function takes in. Please enter a Celsius temp. And this prompts the user to actually input something when we're actually running the code. All right, and now we actually need a second variable. An important note is that the input function always returns a text string. So if we want an actual number we can do math on, we need a float or integer. You can't add text, obviously, so the text version of 23 is going to be different from the float number of 23 to the computer. So you have to convert it through a process known as casting, using parentheses beforehand. So let's create a new variable. We can call this Celsius equals use casting. So now we want to cast a string of input string into a float type and assign that to the variable called Celsius. After we've done that, we can do the actual calculation. And this is something you can just search online. You can always add parentheses for extra security, although it's not necessary here. And then you can print the actual temperature in Fahrenheit. So now it should work, and it will prompt the user first. So let's just prompt the user. All right, the user will be me in this case. Let's enter a Celsius temperature. Let's say 0. So this should be about 32 degrees Fahrenheit because that's freezing point. And yep, it gives us the correct value. All right, now we can also run this again. And let's try 100, boiling point of water. 212, all right, looks pretty good. So do your calculation and it works out nice. So that's all there is to it.